Hello, Pre-Algebra students. This is Chapter 8.7, Function Notation. So far in Chapter 8, we've learned to write equations in function form, and now we're going to learn to use function notation. Let's get started. When you're using an equation to represent a function, it's often helpful to give the function a name, such as f or g. For example, the function y equals x plus 2 could be written in function notation as follows. F of x equals x plus 2. The symbol f and then x in parentheses replaces y, and it's read f of x, and it represents the value of the function f at point x. For instance, f3 is the value of f when x equals 3, and you would write it like this. So this would be the value of f when x equals 3. These are simply two different ways to write the same thing, and this one's much more convenient, isn't it? All right, let's go on to an example where we're going to work with function notation. Let f of x equal negative 3x plus 8. Then find f of x when x equals 5. Okay, so quite simply what we're going to do here is replace every instance of x with 5. And then we simplify after we've completed this substitution. So we have negative 3 times 5, which gives us negative 15 plus 8. And our answer is negative 7. Okay? So when x equals 5, f of x equals negative 7. Working with the same function, f of x equals negative 3x plus 8, find x when f of x is equal to negative 22. Once again, we'll substitute. Negative 22 equals negative 3x plus 8. Negative 22 has taken the place of f of x in our equation. Now we simply solve for x. We're going to subtract 8 from each side to get negative 30 is equal to negative 3x, which when we divide both sides by negative 3, we get that x equals 10. So when f of x is equal to negative 22, x is valued at 10. Work with this function on your own. Let g of x equal 4x minus 5. Solve for g of x when x is equal to 2. Solve for g of x when x is equal to negative 10. Please notice they've just written this in a different way. It means x equals negative 10. And 3, solve for x when g of x is equal to 19. Press pause while you work. When you return, we're going to graph. Now let's graph a function. When you're graphing a function that's written in function notation, it might be helpful to you to first rewrite it in terms of x and y. So we can simply rewrite this equation as y equals 3/4 x plus 1, if that helps your brain to remember what you're doing here. Now let's graph. Your y-intercept is plus 1. And your slope is 3/4, so starting at 0, 1, we're going to plot another point by moving right 4 units and up 3 units. Remember, rise over run. So 1, 2, 3, 4, 1, 2, 3 puts us right here at 4, 4. And now we can connect those 2 points with a straight line. And here is our graph of our function. Here are a few checkpoint graphs for you. Graph each of these functions. F of x equals 2x minus 4. G of x equals negative 3/2 x plus 3. And finally, h of x equals negative 1. Please note that if a function of point C equals point D, you can conclude or assume that the graph of f is going to pass through the point CD. In other words, in example 6, you can assume that your line is going to pass through point x, -1. Press pause while you work. We have a little bit more to do when you get back. Let's finish up chapter 8.7 by using a function notation in real life. In 2001, a scientific balloon like the one pictured here was launched near McMurdo Station in Antarctica. We're going to use function notation to describe the balloon's altitude as a function of time. After the balloon was launched, it rose at a rate of 500 feet per minute until it reached a final altitude of 120,000 feet. We're going to use function notation to write an equation giving the altitude of the balloon as a function of time, and then we're going to calculate how long it took the balloon to reach its final altitude. So let's allow t to be the elapsed time since the balloon was launched, and let's let a of t be the altitude in feet of that time. So we're going to write a verbal model, and then we're going to use that verbal model to write an equation. So our altitude is going to equal rate of climb times the time since the launch. So let's put all these pieces together then. Our altitude is a of t. Our rate is 500 feet per minute. And our time is t. So here's our equation. Now let's solve for the amount of time it took the balloon to reach 120,000 feet. All we need to do is substitute. Our final altitude is 120,000 feet. That's going to be equal to 500 t. Now we simply divide each side by 500 to find our time. And that answer is 240. So it took the balloon 240 minutes, or approximately 4 hours, to reach its final altitude. Okay, folks, that wraps up chapter 8.7 for us. Thanks for your hard work, and when I see you tomorrow, we'll work more with function notation.